Hi everyone, in this video I'm going to show you how to write the equation of a line in slope-intercept form. I have 4 lines here and I'm going to show you how to do the first 2 a little slower than I show you how to do the last 2. Okay, so with that, here we go. Remember that slope-intercept form is of the equation y is equal to mx plus b. And a couple things to note here is that these 2 letters, the M and the B, each stand for something. So the M, think of it as movement, and this represents your change in your Y's versus your change in X's. The B represents a place to begin, and this is always going to be either a positive, negative number along your Y axis, and that will be 0, whatever your Y is. Okay. So with that, let's take a look at the first example here. We have a line that looks quite steep actually. And if we want to write the equation in slope-intercept form, first of all, I'm going to leave these 2 spots blank. So blank x plus blank. And keep in mind that the y-intercept could switch from, or could be either a positive or a negative number. Looking at this graph in blue, we can see that the place where it intersects the y-axis is actually a positive value. Right here we have plus 4. So in this very last part of the equation, I'm going to put a 4. The slope itself describes the movement along the line from the place where we began. So if we want to go from point A, which is what I'll call that, to the next good point on this line, then we have to find a good point that is not in the middle of the square, but sits right at a corner. So if you track my little pointer there, you can see that none of these points along the line quite sit at a corner. So it's very difficult to tell what the input-output value would be until I get to right about here. And right down there, I have another clear point, which I will call point B. And this is located at -1 and -5. So if I wanted to calculate my slope, which I could do, I would have to get the changes in y and change in x. So that's one way to do it. We could also simply count the squares, which is the method I'm going to use for this one. So if you want to go from point B to point A, then you would have to rise up 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So 9 units upward means a positive 9. So far, my slope is going to be a 9. So 9. Actually I need more space than that, so I'm going to open this up to be something a lot larger than that. And so far I have a 9. Now, that's just to get up to level A. To go over to point A, I have to take 1 step to the right. This 1 step to the right means a positive 1. So 1 step to the right. And I'm going to put that as my denominator. So my slope is 9/1x plus 4. The thing in math is we always want to go with what is the simplest form of things. So if we have 9/1, that's the same thing as saying just 9. So I could write the best form possible for this as 9x plus 4. Y equals 9x plus 4. That's my slope-intercept form for this graph. Let's take a look at the next one over here. Again, we want to write this in slope-intercept form, which at the moment is y is equal to blank x plus blank. Okay, so we need a place where this thing intercepts the y-axis, and that's where we begin. So if I track this line, I can see, no, yes, right over here, I have my y-intercept, and that's at -3. So I immediately put that into that last spot. And you can see that I have plus -3, which we're going to clean up later so that we only have 1 sign to look at versus 2 different signs. But for now, let's get the slope. To get the slope, we need to identify 2 clear points on the line. We have one, and it's at point A, but we need another one. And there are actually 2 other possibilities. Either we can go to this one, which I'll call point B, or we can grab this one, which I will call point C. But these are the only other points that we can use because anything else that is on this blue line is very unclear. And we do not want to guess our input and output when we're trying to get the slope of the line. So I'm going to go with point B. And to get from point A to point B, we have to climb up 1 unit, just 1 unit up. Okay, and so since I'm going up 1 unit, my change in y is going to be 1, positive 1. My change in x, which is how many steps to the right or left I have to take, will be 1, 2, 3, 4, 5. I've taken 5 steps to the right, so my change in x is going to be 5. And my slope, therefore, is 1 over 5. And that means we get an equation, y equals 1 over 5x. Now this plus and minus 3 business, that's not something that looks very good to leave that way. So we're going to change the whole thing so that we only have one sign at the very end. Plus negative 3 would be better written as simply minus 3. And the reason we don't take away the minus sign and leave the plus is because the 3 is a negative 3. It's the type of 3 we have, and it's where the y-intercept is located. So we need to leave that as minus 3, and I can rewrite this as y is equal to 1 over 5x, and then minus 3, which looks a lot cleaner than what we had above. All right. One last thing to note about this. What if a person chose point C versus point B? Well, the slope would look different at first, but will it actually be different altogether? Let's find out. If I were to go from point A to point C instead of from point A to point B, this is how things would look different. I would have had to go down 1, okay? And going down means negative 1. So my slope, my change in y so far would be negative 1. Now what about the change in x? Well, from this down, this spot down, I would have to then go 1, 2, 3, 4, 5 units to the left. So 5 units to the left means I'm going in the negative direction, and this would therefore be a negative 5. So my slope, written this way, would be negative 1 over negative 5. Now, is that different from positive 1 over 5? Well, it turns out that they're actually quite the same. There are several reasons to think about this. Number one, when you have two negatives, you get a positive. And number two, these 3 points, C, A, and B, are all on the same line, which means that they are all members of the same family. If this blue line represents the family, those 3 pink points represent members of the same family. So no matter where they are, as long as they sit on the same line, their slope is going to be the same. Going from one point to another point, you follow the same directions. So ultimately, I can say that negative 1, whether I go negative 1 over negative 5, which is like going down 1 and left 1, or I go with positive 1 over positive 5, which is like saying go up 1 and right 5. No matter which direction I take from my point A, I will ultimately end up somewhere along the same line, which means that these two slopes are exactly the same. They mean the same thing as each other, and mathematically they are the same as each other. Okay, let's go ahead and move on to the next 2 examples. And as I said, I would do these last 2 a little faster than the first 2, now that we got the gist of how this works. So here we go. For this one, again, we want to end up with slope-intercept form. Okay, so I need to replace these 2 with their values. The first place is where you begin, and that's going to be my y-intercept, and that would be right here at positive 3. So I'm going to make this plus 3. Then I need my slope, which means I need a second clear point along this blue line. I want to make sure that I grab a point that lands right at a corner of a square and not somewhere in between where I'm guessing where it is. I have 2 other choices, one here and one over here. I'm going to choose this one over here. I'll call this point A and point B. So if you want to go from point A to point B, what you'd have to do is go 1, 2, 3, 4 units down. Okay, so 4 units down means -4, and that means my slope so far is -4. Then I would have to go 1, 2, 3, 4, 5 to the right. 5 units to the right means +5. So -4 over 5, put the x on it, put the equals and the y, and this is the equation of that line. Number 4, and the last one. Once again, we want to complete this equation, y equals mx plus b. These are the two values that we need, and we need to start with our beginning number, which is our y-intercept. That would be here at +4. So I'm going to put +4 right over here. Then I need to get the slope, which means I need to show the change from point A to my next clear point. So I need to look for that clear point that goes right through a corner, and it's right over here. This I will call my point B. So to get from point A to point B, I have to go 1, 2, 3, 4, 5. That's 5 units down, which means it's a -5. So far I have -5. Then I have to go 1, 2, 3, 4 to the right. 4 to the right is a +4, so it's -5 over 4x. So my equation is y equals -5 over 4x plus 4. Okay. Just to wrap this up, remember, you can always turn around and go the other way. A line is bidirectional, so you can go one way, turn around, go back the other way. So if you want to go from point B to point A, all you have to do is go in the opposite direction that you did the first time. So 1, 2, 3, 4, 5, 5 up means +5. So here's the alternate version of this, okay? You would have y is equal to +5, and then you'd have to go 4 steps to the left. So it would be 1, 2, 3, 4 to the left. So 4 to the left means -4, since you're going left on the number line, and that would be a -4 over here. And so my equation would be y equals 5 over -4x plus 4, because our y-intercept is still the same as it was before. So whether you go up and to the left or down and to the right, your equation ends up being the same because you end up on the same line, simply somewhere else and in a different way. I hope this video helped you better understand how to write the slope-intercept form from graphs of lines. Please stop by, leave a comment, and as always, thank you very much for watching. Bye-bye.